Sir Isaac Newton formulated three fundamental laws of motion, known as Newton's laws of motion. These laws describe the motion of objects and are still widely used in classical mechanics to explain the behavior of objects in motion. 1. Newton's first law of motion, law of inertia. An object at rest will stay at rest, and an object in motion will stay in motion with the same speed and in the same direction unless acted upon by an external force. In simpler terms, this law states that objects will maintain their state of motion, whether at rest or moving, unless an external force acts on them. For example, if you slide a book on a table, it eventually stops due to the force of friction. 2. Newton's second law of motion, law of acceleration. The rate of change of momentum of an object is directly proportional to the net force applied and takes place in the direction in which the force acts. Mathematically, this law can be expressed as F equals ma, where F is the net force applied to an object, m is the mass of the object, and a is the acceleration produced. This law describes how the velocity of an object changes when it is subjected to an external force. The greater the force applied to an object, the greater its acceleration will be. Likewise, the more massive an object is, the smaller its acceleration will be for a given force. 3. Newton's third law of motion, law of action and reaction. For every action, there is an equal and opposite reaction. According to this law, when one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. In other words, forces always occur in pairs, with one force acting in one direction and the other force acting in the opposite direction. For example, if you push against a wall, the wall pushes back on you with an equal amount of force.